Good morning, I'm Michael Weiss. I'm going to talk about the interpretation of topic models using topic co-occurrence networks and keyword co-occurrence networks. Topic modeling is a technique for identifying latent topics in a corpus of documents. Those topics are latent because they're not explicitly stated and need to be discovered. This makes topic modeling ideal for tasks like literature reviews. And there's an emerging literature on that. However, this literature does not provide a lot of guidance on how to interpret the topics generated by the model. And interpretation is really the key challenge in topic modeling. So we asked ourselves how we can facilitate the interpretation of topic models by using networks. Let me build some intuition behind topic modeling first. So topic modeling is about discovering latent topics in a corpus of documents. So we have a document here, and on the left side, we have 3 topics that this document belongs to. On the right side, we have a distribution that shows the degree to which the document belongs to each one of those topics. So topics 4 and topic 1 are the dominant topics for this document. In the middle, the highlighted words show which words belong to which topics. This is the process, the proposed process for supporting the interpretation of topic models. So we start by creating a corpus through a search query. Then we pre-process the corpus by lemmatizing and removing stop words. Then we create a topic model. The topic model consists of topics, keywords associated with those topics, and topic weights that indicate how many of the documents in the corpus can be explained by the topic model. From the topic model, we can generate a document term matrix, which shows for each document the topics that the document belongs to. This document term matrix is the basis for creating a topic co-occurrence network. The topic co-occurrence network shows links between topics when they share documents. Then we can go into close reading of the topics, individual topics, in order to assign meaning to them. We generate a second type of network to do this, a keyword co-occurrence network. The keyword co-occurrence network summarizes in the network the top documents associated with a given topic. We can also highlight the keywords associated with the topic in an individual document. Finally, this allows us to produce an interpretation of the topic model. So let's look at an example. Here we have a corpus of abstracts on the triage of security bugs. This was a topic that we were interested in for a recent research project. So the best fit was obtained for 10 topics. And here you see the topics sorted by weight. So topic 5 has the highest weight and is about, as you can see, an approach to classify and assign bugs to developers. The second topic, topic 6, is about using data to analyze security bugs, and so on and so forth. So to create a topic co-occurrence network, we take the document term matrix and we extract the shared documents. So where a document belongs to multiple topics. Such a network creates a sense of the relationships between the topics. And we include documents when they're associated above some minimal threshold. We also use clustering to using community detection to identify common themes in the topic model. This is particularly useful when there is a large number of topics. So here then is an example of a topic co-occurrence network. So what we have here are 5 clusters of topics, starting with this one down here, which has the dominant topic, topic 5. This cluster is about kind of things related to process. Then we have a cluster related to security. We have a cluster related to issues. We have a cluster related to data. And then this lonely cluster, which doesn't have a lot of documents associated with it. To then step into close reading of documents associated with a particular topic. So this is supported by visualizing a keyword co-occurrence network. To that end, we select the most relevant documents for a topic, again using some threshold, and we count word co-occurrences at the sentence level. And we then create a network where a link indicates that 2 keywords indicate in the same context. We can also use community detection on this network to identify clusters of related keywords. So here then is an example of the keyword occurrence network for our topic 5. We see here one cluster for of keywords related to approach, an approach for reporting bugs, and assigning them to developers. We have a cluster on machine learning, which is a method that we can use to do that. A cluster on high impact, so those are the kinds of bugs that we want to identify, and a cluster on tool support. Furthermore, we can highlight for each individual document the keywords associated with that topic. So here again, for topic 5, we have one of the documents associated with topic 5, and this kind of allows us to read the abstracted detail, but also know the keywords that appear in that topic. Finally, we're in a position to create a topic interpretation. So we use the insights gained from the 2 types of network visualizations and the close reading of the documents to produce this. So the topic interpretation is usually sorted by clusters. So up here we have the cluster consisting of topics 5 and 8. And topic 5 is we find that to be about classifying and assignment of bug reports, and topic 8 about security bug triage in general. Then we have a cluster of topics 6, 9, and 12, which are all about the use of data to prioritize, to manage bugs. Then we have a cluster of 1 and 7 related to security issues, and a cluster 4 and 0 related to the distinction between security and non-security bugs. And then we have a last cluster that we can kind of associate with, generally fixing and identifying bugs. So we can now go back to our topic co-occurrence network and assign theme labels to the various clusters. So here the cluster, so we can see that these topics down here really about process. This cluster is really about the use of data to detect bugs. This cluster is about security issues. This cluster is about the types of issues. And then we could say that this cluster is about the use of tools. In conclusion, the key challenge in topic modeling is really interpretation. And our goal was to reduce the cognitive burden on the researcher doing the topic model, creating the topic model, by visualizing topic and keyword co-occurrence networks that provide a sense of the relationships between the topics and a sense of the context of each individual document. We also created a web-based tool, the Topic Model Explorer, to support the workflow for creating Exploratory topic models, and you can find it on this GitHub link. If you have any questions, please feel free to reach out to contact me at this email address. Thank you very much.